Fundamentally, if load's not growing, you don't need to improve efficiency. And that is just changing right now, and it's changing in a really big way.
Greetings, Earthlings, and welcome back to Earthlings 2.0, the show where we imagine how we could be better versions of ourselves and build a collective future we actually want to live in. I'm your host, Lisa Ann Pinkerton. I'm the CEO of the award-winning PR firm Technica Communications and the founder of Women in Clean Tech and Sustainability. Prior to this, I was an award-winning environmental science reporter for NPR and PBS. And if this is your first or 50th time, thank you for joining us today. We're so grateful to have you and bring you these very interesting conversations from around the world. If you're interested in getting more involved in our community, there's a couple ways you could do that. Number one, please consider sharing this podcast with a friend. That is the biggest contribution you can make to the success of the show and spread the word of all these great stories that we're bringing you every week. If you'd like to go beyond that, or if you've already done that, thank you so much. You can join the Substack newsletter. You can join our Patreon and support the team financially. And you can also take our listener survey. That's really important because we want to know who you are so we can bring you more stories that you like to hear. So those are all the ways that you can give back and get more involved in what we're doing. We're also on all the social media channels, so have at it. We're looking forward to hanging out with you there in the interwebs. And thank you to Resource Labs for having us on the network. So today's Tech Spotlight is with a company providing a grid orchestration platform to help utilities operate and build a reliable, affordable, and zero carbon grid. Their technology platform helps utilities navigate this transition to a two-way grid in which both local renewable generation and customer flexibility can be leveraged to provide grid services and achieve affordability and decarbonization goals. Our guest today is Astrid Atkinson. She's CEO and co-founder of Camus Energy. Astrid, welcome to the show.
Thanks. It's great to be here.
Great to have you. So to get started, what are you doing with Camus Energy?
I think your intro kind of gave the headline which we would give, which is that we provide technology, so specifically software, to utilities, focusing on local distribution utilities, to help them navigate the transition to a bidirectional and zero carbon grid. So we're kind of right in the heart of trying to bridge the technology gap to help utilities both be able to provide a lot more electricity demand as demand goes up as we electrify loads, and also be able to navigate a lot more complexity as we're transitioning to an energy mix which might have more demand flexibility, more renewable generation, more intermittent generation, and just a lot more sources of generation. So it's really kind of that mix of complexity and decarbonization is kind of where we're looking to engage and where we help people out.
This dream of the two-way grid that I spoke of in the intro, also known as like V to G. I'm sure people have heard that term.
That's certainly part of it, yes.
That's been a long time desire for a lot of people working in the energy space. And I'm curious, is one of the reasons why we really haven't realized that type of operations with utilities because companies such as yours hadn't come along to provide these platforms to enable utilities to operate that way?
I think there's a couple of different reasons. One of the biggest drivers of change or blockers of change is really looking to the business models and the business needs of the industry that you're looking to engage with. And fundamentally, our technology helps utilities to increase the efficiency of the physical infrastructure of the grid. There's a couple of things that are really driving changes in that today. And one of them is load growth. And this has been a really hot topic. Most utilities hadn't seen more than about maybe 0.5% of load growth year over year in the last 20 to 30 years. In general, for most utilities, load was actually going down as a result of a transition to efficiency technologies. And a lot of that is things as simple as the transition to LED light bulbs. But fundamentally, if load's not growing, you don't need to improve efficiency. Mm-hmm. And that is just changing right now, and it's changing in a really big way. So utilities are, they have that kind of motivation of being able to serve more loads and being really the recipient of energy usage as it gets transitioned from fossil sources like the fossil fuels which run our cars, transit electrification, industrial electrification, and so forth. The utilities are really a big beneficiary of that change as that energy usage gets moved over to the grid and to electrical sources. So there's a big incentive for utilities to look at operating things differently, but there's also a big challenge to them in understanding how to make that change really quickly in order to be able to meet that growing need. So that's one of the reasons why change has been a little slow in the industry. The other is that as we add new energy technologies, particularly to the edges of the grid and on the customer side, every time you add something new, like rooftop solar or EV charging or even something like V2G, it increases the operational complexity that the utility has to manage. And if they don't have already in place really great data tools, software tools, visualization, management tools, all of those kinds of things, that can be really challenging. It's a lot more work for people who already have a lot of work. And it's coming at the same time as increasing challenges from other sources, like a lot of increased disruptions from climate risk, more storms, more fires, more snap freezes, kind of all of the above is making their lives harder at the same time.
So your software is helping these utilities improve resilience and reliability. How are you doing that with your technology?
Yeah, so there's really two things that our technology platform does. The first is data. So we integrate data across the utilities' operational data sources, everything from their SCADA systems that carry their substation instrumentation and their line instrumentation to their smart meter data, their information about where rooftop solar is located, their physical and electrical grid maps, and we bring that together. And then secondly, we bring in data from customer resources and third-party resources, so everything from rooftop solar to virtual power plant providers, EV charging infrastructure, those kinds of things. And we put that in the same context as the rest of that grid data. So firstly, we help utilities to get as good a combined picture of what's actually happening on their grid as you can possibly get from the data that's out there today. The second thing we do is leverage that data to help them manage local resources. So as you add more participants to the grid that can take an action, whether that's generating electricity from rooftop solar or charging or discharging a battery or charging an EV or charging it later, not now, those additions can either put more strain on existing infrastructure or they can help to reduce strain on infrastructure. So they can either be kind of part of the problem or part of the solution. So a really nice example of this that I like is the example of adding EVs to a neighborhood. Depending on the size of the transformer that's serving a neighborhood, it might be serving, 2, 3, 4, 5, 6, 7 houses. And it typically will only take maybe somewhere between 2 and 5 EVs to pose a capacity problem for those transformers. Mm-hmm. So 1 gets added, that's fine. 2 gets added, that's fine. 3, 4, 5 get added, and now the transformer is over capacity. And the utility either has to replace it or it might explode. Firstly, do they know that? Many utilities do know that, but that can be really a challenge for utilities, and a lot of them don't know that unless they invest in doing so. Secondly, do they have tools that can help them to spread those loads out over time? Utilities love more loads because it means that in general, longer term, more or less, they make more money. Yeah. But there's a real balance between their interest in building new infrastructure and in carrying more loads versus how much of that cost you can really fairly and appropriately pass along to consumers.
So how do these utilities use your solution then when you start working with them?
There's typically a few stages that utilities go through when they're thinking about how to kind of pivot their operational model and their business model towards more of a two-way grid environment and more of a kind of dynamic and real-time environment. For most utilities, this is part of their long-term roadmap. This is a change that they know is coming. They may be in different places in that roadmap, or even, not everybody's established their own. Some are still kind of working through it. And so what we find is that, we're providing technology for that future state where things are quite different, but most utilities aren't there yet. So it's usually kind of a phased engagement. They'll usually start with using our data capabilities to better understand the impacts of the changes that are happening on their grid. And then as they kind of move through their deployment roadmap, and as they get more customer resources into their programs and under management, then they'll start to do more active management of those assets. What that could look like is one of the early engagement capabilities we provide with utilities is we will look at their existing energy usage data from their smart meters across their territory. We will help them to identify where EVs are probably located by looking at the charging patterns of behavior within that meter data. And then we can take that as a starting place and factor in their growth assumptions based on the rate of adoption that they're seeing within their territory and kind of help them play the tape forward, not just for their grid as a whole, which is fairly easy. If you have 2% EVs today and it's 10% year over year, you can do that in a spreadsheet. But what we do is help them to place that on their actual grid with their actual equipment. So we can say on this substation feeder circuit, today there are 17 EVs. And as we look forward to 2030, there's going to be 45 or 72 and start to get really precise about like, okay, how does that compare to the low growth plans that you already have in place? How does that compare to the build out plans that you have in place? Have you budgeted the right amount of money for increasing capacity for that? And are there places where those plans might need to be adjusted? But help them understand like what's the difference in cost profile for those assets just being adopted organically versus if you intervened and managed them. So that helps them understand like what's the financial benefit of actually going to the trouble of being able to manage those resources.
I understand that there's probably some other companies out there that are attempting to do the same thing for utilities, but maybe in a different way. How do you stand out amongst some of those other organizations?
So there's a couple of things that I think are really special about us, and one of them has to do with team background. So myself and about half of my team came in from the tech space. So I worked at Google for about 15 years, and I was part of the team that helped develop cloud computing when it was new in the industry, and also led up a lot of Google's work around developing reliable systems and systems infrastructure as we kind of went through the transition from a world where software like runs on one really big computer, and if we're moving from a world where we have a few really big power plants to one where we have lots of little ones all spread out all over the place. And they're connected by a network that's not always totally reliable. They're not always going to do what you tell them to do. You won't always know exactly what's happening with them. But when we went through that transition in the tech industry, by managing it carefully and managing it with a perspective towards building a reliable system, we were able to build systems that were utility grade reliable while also being about 1,000,000 times the size. And that was a really big achievement that helped to fundamentally change how we interact with technology and what's possible. The other thing that I think is really interesting about what we do is that, there's been a lot of really great technology work done within the grid industry and with the electrical systems industry that has had trouble kind of bridging the gap from the lab to the field. It's difficult for researchers to get access to real utility data. It's difficult for them to get real utilities to deploy, stuff that's new or innovative. There's a lot of overhead associated with it. So one of the things that we kind of intentionally did when we started the company was to say, like, reinvent as few wheels as possible. Our goal is to bring really well-tested technology from the internet and hyperscaling side, but we also want to leverage really well-developed and really well-proven technology in the grid space that's had trouble really getting to market and help it to reach market at scale. When we were thinking about, how do we want to build our software solutions in this space, we don't want to reinvent the wheel. We want to use things that work. So what we did was actually engage with the teams who were building that, look at the results in the field, and then go ahead and kind of leverage that work that had been done elsewhere. It really, I think, lets us move much further and faster because we also really look to leverage stuff that we already know works.
And I understand you have a couple of customers already in this space. Can you give us an example of one that you're working with now to help illustrate the results that this utility is getting or this customer is getting from your work?
We're at about 14 utility scale customers today. That breaks down between two major categories of utility. We've got a set of customers that are in the public power sector, that are cooperative utilities, usually serving rural communities. And then we have some customers that are in the larger utility, investor-owned utility sector, which typically serve larger populations and larger service territories. One example of a customer that's in that public power sector is Vermont Electric Cooperative. They've done a lot of work in the grid technology space and evaluated a lot of different technologies. But that's actually one of the biggest reasons that they wanted to work with us, because by the time you have, one system for managing your battery program and another system for managing your EV program, maybe two, depending on how many EV programs you have, and then, you've got your grid information decently collected, but it's in a different place. It starts to get really complicated to reason about, what's going on my grid? What would actually be beneficial? Where are we today? What's going to make the most sense in terms of where we invest moving forward? What gives the most benefit to our customers? All of these questions, right? So we work with them and firstly provide that kind of sort of single pane of glass view of all of the different things that are happening on their system. And then that powers analytics use cases like the ones that I described earlier, right? Like we help them to identify where are their EVs on the grid today. If you were to manage EVs in places where there might be grid constraints, what would be the value to customers? What would they save by avoiding building out more grid infrastructure? Could you, prolong the life of transformers, those kinds of things? So we started with them on those like kind of more data-focused use cases. And we're now in the process of rolling out controls use cases, which they are using to manage those costs and also using as kind of an iterative feedback loop to help demonstrate at larger and larger scale the benefits of engaging with customer resources, specifically in terms of managing customer costs and keeping bills low for members of the community.
What are some policies that you think could be adjusted or innovated to support the work that you're doing at Camus?
The relationship between policy and utilities is a really interesting one because it's a much more dynamic part of interacting with utilities than is true in other industries, just because of the nature of utilities as a kind of regulated monopoly. There's a couple of examples that I'd give of policies that have already been put in place, what the relationship between those resources and the utilities that host them should be, kind of left that as an exercise to the reader. But the fact that it requires that access be available and provided means that local utilities kind of they have a timeline for needing to deal with better visibility into understanding what's happening on their grid and better tools for kind of coordinating with the different participants in their ecosystem. So that's great for a company like us because helping people deal with enormous amounts of data scale and coordinate millions of things is kind of what we're here for. So that's an example of pre-existing regulation that is an accelerant for us. There's a lot of parallel conversations happening in a lot of states around how to best use customers' money, right? What should we invest in as a utility? Like what resources are going to make the most difference? What things are going to make our dollars stretch further? What things are an improper use of funds? And those conversations are typically data-driven today, but the data that's used is really difficult to obtain, is used differently in every conversation, and it's not necessarily very transparent between the utility and the regulator. So some things that we think could be helpful are more general standards for data availability and insight as utilities look at kind of planning and operational use cases. And that also extends to looking at things like data sharing as part of these relationships between virtual power plant providers and utilities. So one of the things that we're looking at on the technology side is helping to establish an interface for distribution utilities and virtual power plant operators to talk to each other as we go through this transition under FERC 2222 to them being much more active participants in energy markets. Now, there's a technology piece of that, which is where we can help say, like, look, this is the data format, this is the protocol you should use, here's the data that you need to provide. But there's potentially also a policy piece of that too, which is like, hey, everybody, you should provide the following types of data. This is what utilities must have access to. This is what aggregators must have access to in order to be successful here. Mm-hmm. And so that's a place where we think that there's definitely a role for policy. And policy could be really helpful.
So you mean we need to have a standardization of data and everybody's sort of working off the same? I'm shocked that
Uh,
that could be a solution to some
there's,
of our problems.
the utility industry loves standards. It has so many. So part of the process is also just saying like, hey, everybody should use this standard. And then a really important part of that too is like you don't want to spend 10 years discussing a standard before you do anything. It's really helpful if you can kind of take that, demonstrate it at scale, and then kind of work backwards to like the standardization process. And that's helpful for regulators too.
Well, we're a futurology podcast, so I always end our interviews with looking towards the future. And when you're thinking about building a more resilient grid in the future and the work that you're doing at Camus, what do you expect to see in the next, let's say, 10 years?
This is a question that's really close to home for me because I live in an area of the country that's seen a lot of grid disruptions and increasing challenges around infrastructure reliability. So I'm in the hills in California in an area that's pretty fire prone, like most of California, and didn't used to be, also
Hmm.
like most of California. Um, and what we've seen here is really increased risk of weather disruptions. So, fire risk that's gone just way up. Winter storms that have become more intense, they cause landslides, knock over trees, which knock over power poles. Um, Utilities in the state have struggled with the need to reduce the risk of starting fires from their infrastructure, but that also reduces reliability for customers because one of the ways you don't start fires is shutting off infrastructure when there might be a risk. So people in California have seen a lot more power outages. That'd be one thing if it was just California, but those kinds of impacts show up all over the place in different ways. So Texas has also seen a ton of reliability challenges driven by extreme weather, in their case, hurricanes and big storms, snap freeze, all of this kind of thing. Folks in the Midwest are seeing increased flooding impacts. Folks in the Northeast are seeing increased somewhat fire, but like really a lot of like winter storm impacts. I think we're just at the start of seeing what that's going to mean to us. So utilities aren't really starting from a status quo. Like it's getting worse today. Um, the tools that we have for managing that today aren't great. We want to stop starting fires, shut off power.
Yeah.
When you shut off power, you lose communications, you lose cell towers, you lose critical infrastructure, you use fire stations, police. Um, the first couple of years this was happening in California, we were subject to 3 to 5 day power outages to prevent fire risk. And after the first day, we lost cell phone communications. And there were fires, and you didn't know if you needed to leave. Landlines also shut off because they also require power. People lost water infrastructure. They lost the ability to communicate within and outside their communities. So if we don't get this right, things will get worse.
Hmm.
Having said that, we've also seen a lot of communities start to really evaluate smart investments in things like making it so that rural communities can operate by themselves in an island environment. That's something that utilities around the country have been working on, something that PG&E is working on, a utility that we work with in northern New Mexico, Kit Carson Electric, they're working on that. We're helping them with it. That's something that individuals are investing in. Like, I ended up putting in batteries. All of my neighbors have generators. And so looking at ways that those investments that both utilities and individuals are making can help make things better for everyone instead of just the person who buys the generator, I think is a really critical part of making sure we get a better outcome here. I think there's every possibility that the distributed grid of the future can be a lot more reliable than the grid that we have today, or at least reliable enough that you don't notice any difference. And I have a lot of optimism about that because we have done that in other industries. Other industries have adapted to really big changes. I helped drive this in the computing industry. It's happened in telecommunications, the internet industry. It's happened in aerospace, although not all current examples are really good examples of this. Um, and this is a problem we can solve. We can
Hmm.
fix this. The grid can be affordable, the grid can be reliable, and the grid can be decarbonized. But we need to move quickly, and we need to make sure that we can put all of our available technologies to work.
There's grid disruption everywhere, and certain communities have figured out how to create band-aids to live with those disruptions, right? I
Yep.
remember a story from a battery salesperson I was talking to at some conference years ago. He was trying to sell lithium-ion batteries, and he said he wouldn't even try to go to the Dominican Republic and sell lithium ion batteries because the culture there is surrounds lead acid batteries, and everybody's really good at maintaining them, and everybody has one in their closet because the grid goes down like 13 times a day. So you have your own battery management system for your
Yeah.
own utility or for your own energy. And I thought that's really interesting. And if utilities don't get a handle on this resilience, that's the way people are going to go.
We've seen really big step changes happen quickly. So I think the telecom industry is a really interesting example. Um, in developed nations, in places where there's been phone infrastructure for a long time, it was a slower transition from wires to wireless. In places where there hadn't been wired telecommunications infrastructure in place already, particularly looking at like some African nations and places that are a little bit more spread out, they very quickly just went straight to cellular for everybody. And that really increased universal access to things like cell phone technology and even the internet. But it wasn't a process of like slowly adapting the wired infrastructure to be more resilient. It was just completely changing how you thought about the problem. And I think that some of what's going to happen in the grid will look like that as well. But I think we're just in the very early stages of it.
Well, thank you very much for being on the show. I really appreciate your time. This is very fascinating.
Thanks so much. It's really, really great to be having the conversation.
Yeah, you're welcome. And Earthlings, we will see you again on another turn of this beautiful blue green space flower that we call home.